All right, so that's chapter 6, section 6, last section in the chapter, the central limit theorem. So this is a very important topic or idea. I like to abbreviate this the CLT, right? So you'll hear me say CLT. What I'm talking about is this idea called the central limit theorem, okay? So again, CLT. So it has to do with means. So we're still doing means problems here, not proportions, okay? CLT. All right, so the first thing you're actually going to do is you're actually going to go do an activity edge elastic. The idea here is we're looking at when we are measuring or finding means, sample means, and the population is non-normal. So you'll see that when you do that, the activity, you're not going to be dealing with a normal population, and you're going to try to come to this CLT conclusion. All right, so go do that and then come back. All right, so hopefully you've come back and now you see the main idea of this central limit theorem, the CLT. So it says if you draw an SRS, a sample of size n from any population with mean mu and finite standard deviation sigma, the central limit theorem says that when n is large, the sampling distribution of the sample mean x bar is approximately normal. And when we say large, we mean that n must be at least 30. N must be greater than or equal to 30. Okay, so keep that in mind as we go through. So if the population is non-normal, could be skewed, right? If it's non-normal, and your n is less than 30, you cannot do this problem using a normal distribution. But as long as n is at least 30, you can do that. So this right here talks about our condition for a mean called the normal large sample condition. So remember, for proportions, we have what's called the large counts condition. You handle that. For means, you have what's called the normal large sample condition. So this says the distribution of x bar, again, sample mean, will be approximately normal when either, so only one of these has to be true. Either one of these is true. Number one, the population distribution is approximately normal. So they say normal in the problem. At that point, it doesn't matter what the sample size is, you can do this problem using a normal distribution. Okay? Or, not and, or the sample size is large. If the population is not normal, then the sampling distribution of x bar will be approximately normal in most cases. So we're going to say in all cases, when n is at least 30. Okay, and that's today's idea. All right, so keep that in mind. All right, so example one, a few more pennies for your thoughts. So again, it says, Mr. Ramirez's class did the penny for your thoughts activity. The histogram shows the distribution of ages for the 2,341 pennies in their collection. So again, this is the population distribution. Okay. So the first thing we want to do is we want to describe the shape of this graph. Now look, right? If I try to create a curve, I think you can easily see that this is skewed to the left. So this is non-normal. Normal would have to be a bell-shaped, roughly symmetric curve. So this is a non-normal population. So part A, it says describe the shape of the sampling distribution of x bar for SRSs of size n equals 2 from this population of pennies and justify your answer. So here's our response. Because n equals 2 is less than 30, the shape of the sampling distribution of x bar will also be skewed to the left. And this is because it does not meet, or it fails, the central limit theorem. Okay, I'm emphasizing CLT because I want you guys to remember to use it on your upcoming quiz. Okay, so again, less than 30, we cannot say it's normally distributed because the population is not. Okay, so part B says, now describe the shape of the sampling distribution of X bar for SRSs of size n equals 50 from this population. Justify your answer. So now we say because n equals 50 is greater than or equal to 3, it's at least 30, the shape of the sampling distribution of X bar. And again, when you're doing this in Edulastic, please put the words X bar, right? Right. If you can't find the symbol, then just put X bar. I'd appreciate that. Will be approximately normal. And that is because it passes the CLT. Great. And there we go. Okay, so there is how we justify whether our sampling distribution for X bar will be approximately normal or not based off of a non-normal population. Okay? All right, objective 2 is coming up with the big problem.